So now we're recording. All right. So we've created the class main, and we've created the class person. And in our person class, we went ahead and created this constructor, right? And it's going way off the screen here. So for visibility's sake, I'm just going to hit enter and bring it down in line. And it's telling us a problem right now. The problem it's telling us is we don't have a default constructor anymore. As soon as we create a constructor with all of these parameters that we're passing in, and we're setting them to these variables, as soon as we created this constructor, we took away the default constructor. So if we're looking at the main class where we are calling this create, it's saying, hey, there is no constructor, no default constructor called person. So we can fix that pretty easily. We can come up here again. We'll go to our generate. Again, if you're needing to figure out how to get to that, you can go to code. Let's see. Where did it go? Go up to code.
You passed it?
I passed it. I sure did. Generate and then select constructor. And in this instance, we'll select no constructor because we want a default constructor. Now, if we save that, now we have a default constructor called person, and we have person here, right? All right, let's go back to our main class. We can see that the error is gone. So now we're creating, by default, a person, right? We're taking the person object and we're saying person, and we're not using the this, but we could say this person equals new person. And now I've created the implementation for it. And very similarly, I could do it this way. I could say new, my keyboard's not working, person. And I've created a new person. Okay? All right, I'm going to take out this create just for a moment in this class, and let's create a different method. Let's call this method public void print person. And we're going to allow it to accept a person object. And we're going to use system out print line person. Now, this class here, print line, by default, it accepts an object class. And person, by default, extends from object. Now, you may be saying to yourself, how does it extend from object? I don't see extend up here. By default, any class you create automatically, by default, extends from object. In fact, me typing this is redundant. Okay? I don't have to type that. But because it extends, by default, all classes extend from object. Okay? Because it does that, when I call system out print line allows me to accept any object, as you can see here. Print line will take any object. So person is that object. Now, if I go ahead and try to print this, I'm going to go ahead and say PSVM. Okay. I'm going to create an instantiation of the main class, main m equals new main. And then I'm going to say m dot print person, and I have to supply it with a person. So I'm going to come up here. Let's see, I already have a person I've created, right? So I should be able to say this dot person. And that's not going to work because this can't be accessed from inside a static context. So instead, I have to use the m because that is the main M is the variable that represents the main class, and from it I can access the person. All right. Let's pause there and let's talk about what's happened. Anything not make sense so far? Anything not make sense? Ezra?
How did you do the constructors again?
How did I create the constructor? Over here?
Like all at once?
So you're going to use the generate. You go to constructor, and then just use your shift key and select it all,
Okay.
and then click OK, and that'll create it for you. Okay? All right. So the question is, when we print this, what will it print? What do you think it's going to print on the screen?
Person?
It'll print a person,
First name, last name, character, letter.
but we haven't really said anything about this person, have we?
Yeah.
All right, so let's go ahead and just use the little play button here and just see what happens. Well, there's our person. Have you all met him before? No? He's a really good guy. Or girl. Or a person. We don't know who he is. She is, right? This doesn't tell us a lot about this person, does it? All right, so let's talk about what we might want to know. Let's populate our person. So I'm going to come up here and I'm going to populate it. So my person, let's see, what is the first parameter of my person?
First name.
First name? Ezra. What's Ezra, what's your last name?
That's Y.
T-O-W-A-I. Okay. And then Ezra's, let's see, hair color is brown or black?
I think brown.
Brown? Okay. Ezra, your eye color?
Brown.
Brown? What was the next parameter? Is the date of birth, right?
For height.
A height? And you made it a double, so we have to be accurate now.
5'5", so 5.5.
5.5? Okay. And then let me do this. Bring it down a new line. We can kind of do this to get things a little easier to see. And we still have one more parameter. We know it takes a date object, so I'm just going to say new date, which is basically going to tell us that Ezra was born today, years old. Okay. All right. We've got this information in here now about this person. So what happens when we print the person? What do you think is going to be displayed? Some of you might be ahead of me and you might be printing it and going, I don't understand. Let's print it and see. We'll run the class. Well, there's Ezra.
Yeah.
Yeah. So some of you may be going, I don't get it. What am I doing here? This doesn't make sense. This is not meaningful to me. This is a identifier that basically says this is the object or the class and a memory location. We've actually identified the memory location on the hard drive, not on the hard drive, but on RAM. And that's what the toString method produces. So let's go back to our person. Here is our person class that we created. And let me know as soon as you see the toString method. Does anyone see it? It's there, believe it or not. That's because person extends what object? It extends object. And inside of object, by default, you get all of these methods. And the method that you get is the toString method. So let's take this person object a step further, and let's go ahead and create a new method, and we're going to call it a new method, and we'll come down here to the toString. Do y'all see that? And we're going to allow IntelliJ to generate the toString method for us. Okay. And by default, it's going to select all of the data attributes. We're going to say, yep, that looks good to me. And now we've created a method called toString, which presents a textual representation of the person object. All right, a couple of things. We're using override method, override annotation. And this basically marks this method and says, hey, Java compiler, we're overriding the default toString method. Okay, overriding the default toString method. Now that kind of signifies some things. You could technically create another class, and you could call this class a student, and the student extends person. You got to think about the power of what you're doing. What happens if you create another class and extend it from person? What do you get for free in that class? Alan, right? Yeah. Okay, awesome. What do you get for free? Anyone know? You get everything that's in the person class. So whatever methods you've created, whatever properties, you get it all for free. But now you're reusing it and you're creating a class that offers greater specificity. So let's go ahead and first of all, we've created the toString method. Let's go back in here again to the main class, and we're going to run this again so we can see now what Ezra looks like. Okay? So we're going to click main and run, and now we see a proper string representation of Ezra when we print it. Right? Okay, so this is by populating the person. Let's go ahead and take this a step further though and do what we talked about. Let's create a new class, and we're going to call it student, and student is going to extend from what? Person. All right, let's go back to main. And I'm going to create a new private, whoops. I don't like it when it messes up my formatting. We'll create a new class and we'll call it student. And the student is going to be a student. This is going to equal a new student. Now, interestingly enough, you can see here what we have going on, right? We highlight over this. And you may be asking the question, well, didn't I already create a constructor that did all of this stuff? How come I'm not getting it for free from person? Well, because you didn't specify. You didn't tell it, hey, I need to also now override the constructor. So if we go to the constructor here, and Before we do that, though, what is an attribute of a student that not all persons have? What's that? ID. That was a good one. All right, let's do private, long. We're going to be very specific and say student ID. Okay? Now, I'm going to go ahead at this point and I'm going to generate a constructor. And I'm going to use, click on both of those and click OK. And I'll say OK to that. Now I have a student that can accept a student ID, right? I have this student, and notice what IntelliJ has done for us. It says, well, because we know that the person object has all of these properties, we're going to go ahead and create a constructor for readability's sake. Again, I'm going to do this so you can see it. Okay? We're going to create a constructor that has all of those parameters, but we're also going to include the student ID. Yeah.
What's the super?
I was just about to get to that. This is what I'm trying not to make a joke here, okay? This is the superpower of Java. That was a dad joke. Okay, that really was lame. This is, super means, hey, what is the parent class it extends from? And so super implicitly is saying, give me the constructor for the parent class.
It's highlighted there.
Yep, you can see it. Yep. So we still have one problem, right? What is the problem? By default, because I've created these two constructors, what have I now taken away? It's the same problem we ran into with the person class. What constructor have I removed now? I've implicitly removed the default constructor. And so if we want to have that default constructor back, we could just simply type public and I know I can type here eventually, student, like that. Now we have put back in the default constructor, and you can see that IntelliJ says, okay, now the problem has gone away. All right, let's talk about something that's you're probably wondering about, the similarity between a constructor and a method. What similarities do we see here? Let's create a method real quick, just so we can talk about it. Public void get student ID. Oops, let's make this return a long. Okay. This will use the return method, this student ID. All right, looking at, well, let's create another method real quick. We'll call this one public void set student ID. And this will take a long of student ID. And this will be this dot student ID equals student ID. All right, looking at the constructor here, let's say this constructor and this method. What are some things that are very similar between them? They both have some type of method signature, don't they? We see the parenthesis, we see parameters that are being passed in. They both pass in a long parameter called student ID, right? The constructor implicitly does not have a return type, right? Let me rephrase that. It does not have a return type in the natural way that you would expect. It actually does return something because it creates it in memory. The constructor, its main responsibility when the constructor is called is to say, hey RAM, I'm going to take and create this object and store it in memory. And this object is going to be whatever I've said it's going to be based on the constructor parameters. Whereas this method, setStudentID, is a mutator to the object that was created in memory. This method here, setStudentID, will only work if the object exists in memory. Now think about that logically. Okay, let's go back to our main class, and I have a private member variable right here called what? Person. And what is it doing? It's creating something in memory, right? Yeah. Now, if I wanted to access something on that object, person, well, let's take a look at it and see what is there to access. I can access the toString method, and that toString method is only available if the object exists in memory. It has to exist in order for me to call the method it's based on, right? Now, if we look at the person class, we don't have any mutators in here, do we? We just have a way of creating the person with these attributes. But we don't have any way of actually modifying the person after it exists. You guys see what I'm saying? It exists, and it is what it is in memory. The student class, we can actually change the student ID after it's created. All right, so let's go back to our main. I've got a student here, and I'm basically just going to copy this information here because I know that the method signature is pretty identical, except we need a student ID. And Ezra, what is your favorite student ID ever?
Big number.
Huh?
Big number.
Yeah.
100177.
I'm taking it, it's probably like the cafeteria ID
Yeah.
from Kagman, right?
Yeah.
All right, so what is it?
100177.
100177. And we probably, that's probably a safe number to use, right? Because they're going to generate a new one every year. And yeah. Okay. Because this is a long, this ID, I have to put the letter L at the end of it. Okay, you guys see that? The letter L specifies that this number is a long. If you remember, by default, if I don't do this, it says, well, this number is implicitly an integer. And I have to specify the memory location, how much memory it's going to take up in RAM by using the L parameter. Okay? All right, so now I've created a student, and I have a print person, so I wonder, can I print my person? What do y'all think? You think I can print it? Print the student? We could try. And what is it telling us? It tells us it works. Do you all know why it works? Well, this is like that fun little thing we played in, you guys probably played around logic statement in geometry, where you said a A square is a what? Is a rectangle, right? But a rectangle is not a square. You see the idea here? A student is a what?
Person.
Is a person. But not every person is a, right? It's the same type of logic rules apply here. So we could say, yeah, a student is a person, and so therefore I can print it. Well, what happens when I print it? What do y'all think happens? Let's print it and see. There we go. It printed, but it didn't give me any more identifiable information about the student. Why is that? Why do you think that is? We know that this is from what? That's from a person, but what method is that from? Exactly, it's from the toString. So let's go ahead and take a look at the person. We see the person there, and we see the toString. And toString overrides what? It overrides what class implicitly here? I'm stretching your all's brains. It overrides the object class, right? So when I call this method, hey, print the person, what toString is it going to call? The object class or the person class? Well, we're overriding, right? The person toString, so it's going to call the person. Let's play around with this. Let's go ahead and create a new toString. So I'm going to go to generate, go to toString. I'm going to say yep. Now we do that. This is going to get interesting, isn't it? Let's run the main method again and see what happens. So think about what happens there. The first time it comes through on print person, it calls that person's toString method. And that person's toString method is this. Right? The second time we call the person toString method, the person at this instance is what? It's the student, right? Here we go. And the student's toString method is that. The JVM, the Java Virtual Machine, knows which object it should call, which object method it should call based on what is handed to it. So the student comes in and says, yep, you're a person, I can handle you. And it prints the person's toString method. So for a generic person, it's all of those details. When it comes to the student, it says, yep, a student is a person, I can print it, but it only prints its toString method. So if we wanted to change this and have the student print more, what could we do? Maybe we could do something like this. We could say plus super toString. Because super does what? What does super do? As opposed to this. This calls this. Super calls up there, right? It goes up the inheritance chain. So the inheritance chain for a student, it comes from a person. So if I print this, and if we were to run this again and look at that, it would just be a mess, right? It doesn't know what to do there. In fact, it gives a Stack Overflow because it's calling itself upon calling itself upon calling itself upon calling itself. Implicitly just keeps calling itself. Yep.
Kind of how do you, like, debug that process and debug that?
How would you debug this?
Like you would go step by step and all that. I remember you showing it like a couple weeks.
Oh, like put the debug, just click on the left-hand side, and then when you go to run, let's see, you got to go to the main, and then right-click here and go to debug. And so now when we do that, it's going to stop at the first breakpoint, which in my instance, the first breakpoint is after the print person is called. So it's not a good spot. But now you can see, let's just look at what we did here first. Now we said super toString, and super toString is going to give me person plus the student, and then there's the rest of our information, right? All right. Any questions so far? How many of you do not understand yet what's going on? A little? Okay. What part confuses you? Thomas, I'm just going to ask because you're probably not alone. There's probably others that are too afraid to ask. So what part is confusing for you? Right here? Me adding the super or the override of the toString? Okay, so this annotation is basically, it's a marker that says to anyone looking at the class, we're overriding something that it extends from. Anytime you see override, you can say, okay, this class is overriding, is extending from something. This class extends from something. And this method exists at the higher ancestor, right? So the higher ancestor to the student is the what? Person, right? So override says this toString method is overriding something at the higher level, right? And when I say return, I have this basically this string literal with the plus symbol, the student ID, right? I'm adding this in here and I'm returning that. But I also do another plus symbol and I say also call the parent toString, right? Anytime you see super, it means just think of your parents as just being super, right? All the moms and dads would love to hear that. Hey, my kids think I'm super, right? That's literally what it means. Parents are super, right? So the super class is the parent class. That parent class is identified in Java as super. I'm not making a value statement. It's just, I think it's comical that it kind of works out that way, all right? All right, does that make sense? Yeah? All right, anybody else have questions? All right, so let's maximize this again. We could take this even a step further, right? What other types of persons are there? What's that? Staff? I can't see who's saying that. Oh, staff. Okay. So let's do that. Let's create a staff. Say Java. And we'll say the class is staff. And staff should extend from what? Person. All right. Let me ask you this. Sometimes we might think it might be cool if we could extend from two classes. Java, as a programming language, will not allow you to have multiple inheritance. Okay? What I mean by that is I can't say extends from person and from student. It will not allow you to do that. You can only extend from one class. And of course, if IntelliJ is going to tell you that. You cannot extend from multiple classes. There are programming languages where you can extend from more than one class. The catch when you do that is you have to think about logically what happens. Now, there are certain logical fallacies that we know exist, right? For example, you can't have a circle extend from a square. Just doesn't make sense. And so if you start creating classes where you try to create logical fallacies, say like for example in C++, you could do that. You could create a logical fallacy. And it's going to create all kinds of weirdness underneath, right? It just doesn't work, right? So in Java, you can only extend from one class, okay? All right, so there you have public class staff extends from person. You would not go and say staff extends from, I mean, you could do this. This is valid, although logically it doesn't make sense, right? But as far as the parameters, it will start to pull all of the same data objects from the student class. All right, we've covered a lot of the basics of classes. Let's go ahead. I'm going to, let's go ahead and finish this up here. And let's say a staff extends from person, and we're going to say private long staff ID. We're going to go ahead and give it a constructor. And we'll go ahead and use both of those. Okay. And I'm going to create it a default constructor just because it fills all that out. We'll also come down here and we'll create a new toString method. And we'll say OK. And we have a staff as a person. If we come back to our main method, let's go ahead and copy our student here. And we'll say, I'm just going to paste this in and say private staff equals new staff. Okay? And all of the parameters work because it's the same number of parameter entries. If we come down here to our main method, we could say print person staff. Okay, again, is referring to which variable that we've created, which private variable, or I'm sorry, local variable. Refers to what? It refers to the main, right? Because we declared it here. This is the class, this is the object name we gave it, and we said, okay, create this object variable by calling the new main method, right? Now we have a handle on that object called which is of type main, and we say, okay, call the print person method, and we're passing in m.person, m.student, m.staff. There we go. And if we go ahead and run this again, we'll see what we've printed. Okay? All right, so this kind of gives us the basics then of classes. And the idea behind classes is you're delegating out the functionality to separate design structures. Okay? You're writing the code and you want to delegate, you want to create all of these different types. Let me give you an example. Those of you who are working on your projects may immediately see the importance of like, well, hey, I could have a class that represents some type of attack variant, right? I could have a class that represents a hand strike because a hand strike is going to have all of these properties. I could have a class that represents a potion. I could have a class that represents all of these things. I could have a class that represents the person that's interacting with all of these objects. That's the idea behind it with programming. We're starting to create objects that have specified purpose and design behind them and how they interact. Okay? All right. Let's switch back over here to our notes. And we've talked about class members. We haven't talked about implementation yet. I'll deal with implementation in a moment. We're probably about a week ahead when it comes to inheritance, because I think next week you're going to get into more of inheritance and polymorphism, and actually it's 2 weeks away. We'll dive deeper into this topic of inheritance. Okay. Next week we're going to be looking at memory management, input and output, different ways that you can write and accept data. All right, but let's go ahead and consider some of the other topics here. We have persons. All right, test benches. Let's go back. So here I have a main, a person, a staff, and a student. And I'm supplying it this data, and I'm expecting it to output a certain amount of data. Let's go back to our person class for a moment, and let's go to, where did you go? Generate. And we're only going to create these getter methods. These are accessor methods. And I'm going to go ahead and say, go ahead and give me all of those. Okay. I'm going to go to my student and do the same thing. I'm going to generate and say, give me a getter method. Oops. Oh, I've already got a getter method. Haha, right there. Let's go to my staff. I don't have any getter methods in here, so I'm going to do the same thing. Generate a getter and staff ID. Did you raise your hand? Oh, okay. All right. So you should have a getter method called getStaffID in the staff. In student, we had a getStaffID. Excuse me. Load that up again. We have a getStudentID. And in the person, we have all of these methods. Okay? All of those methods. So let's go to our main. And I'm going to do inside of the print person, I'm going to have do another system out print line just so we can see what's happening. And I'm going to say person dot get first name. And for our purposes, I'm just going to comment out this line up here, okay? Because I want to be able to show what we're printing in a better fashion. And then underneath it, I want to say system out print line person get class. Because I want to print out the class that comes for each person that's printed. Okay? So let's go ahead and run this. And we can see right away it's printing out the status of each person object. The first one is Ezra, that's class person. Let's make this a little easier to read. Let's do, take out the print line, and at the end I'm going to say plus, minus, like that. That way we'll have the name of the person on the same as the class. All right, we'll run it again. Excuse me. So we have Ezra of class person, Ezra of class student, and Ezra of class staff. You guys see how that worked? We're printing out the class names of each object. All right. So let's take a pause here and talk about a test bench. A test bench is a way of validating what you have. And you could create a test bench called test person, okay? And I'm going to go ahead and do that real quick. We'll just go ahead and create a test bench. We'll call this our test person class. And we're going to give it a public static void main method, okay? And I'm going to create, let's see, let's do test person equals new test person. So we have a handle on the object now in the test person class. And I'm going to create a method called test, let's see, private void test underscore person underscore name. And it's going to take in a person object, and I'm going to say person get first name and what we could do is we could say assert, I'm trying to remember the syntax for this. Let's just do this. If person dot name, we're going to say string test name equals ignore case test name. And typically when you write a test bench, you're doing it where you're testing for the negative response. And so we're going to say if the test person does not equal the test name, then we're going to system out print line fail going to print what is did not return expected name. All right. When we create test benches are meant to validate that what your method does what you state it does. Now there's a lot of frameworks out there that do this. There's JUnit is a framework that you can download and use in your classes. But for the purpose of validating what your class does, you always want to write a test case. And the test case then should be something that's ran every time the class is compiled. So in this example, I've got this person, and I'm going to validate that the name of the person is going to match. And if it doesn't, it's going to throw an error. Okay? So what we could do then is we could say person equals new person. And for sake of time, I'm just going to copy, let's see, where's our main method at? Oh, here we go. Okay, so I've got my person object, and what do I want to validate? Well, I want to validate that the person's first name is what it says it is. So the way I would do this is I would call my test person, call my test person object, call the method that I'm going to validate, and I'm going to pass in my person object, and I'm expecting it to equal Ezra. And if it doesn't, it's going to tell me that. Okay, so I'm just going to run just this class, and nothing happened, right? Because it passed the test. Let's say that my test case did not consider the fact that Ezra's first name was all in caps. Well, when I run this again, it's going to validate, does my test person equal what I expect it to equal? Am I running the right case? Actually, let me back that up. There we go. I'm equals ignore case, right? All right, so let's say that my test name, I'm expecting that the test name to be that, right? So we'll run it again, and the test case then is going to give me the response. I'm expecting it to always return what I've said it's going to return, right? All right. This represents a test bench. Test benches may seem redundant to you. In Java programming, you always want to have a test bench for every class that you write. Now, for this class, meaning this course, I'm not going to require you to write test benches, but as you move on into the real world, and if you continue in programming, you'll be required by your employers to create test cases, unit test cases, test benches to validate your code. Okay? Think of a test bench the same as a test that you would take in a class. If you said that you've inputted all of this data, then you should be able to spit out that data, right? That's what a test case does. It validates that the object says it knows what it knows. It is what it is. Okay? Any questions? All right. If there are no questions, I'm going to move on from test benches. Everyone understand what they are, though, right? Okay. All right, well, let's go on. When you're writing a unit test case or a test bench or whatever, you're looking for 100% code coverage of your code. So the reason this is important is you may write code at some point, and you've got the logic in there that says it's going to do what it's supposed to do, and then someone comes along and changes your code. Right? This happens all the time. You're not the only one who writes code and it stays with you forever. You may write some code and then 5 years from now you move on to another position. Your code is still there, and the test case, the unit test case that's written, the test bench software that's there, ensures that structurally someone's not messing with it and causing problems. It's meant to validate and keep the code safe. All right? Okay, let's move on here. Let's talk about constructor overloading. Let's go back to our student class. And here is an example of constructor overloading. We have a student constructor, and we have a default constructor. So the student structure is overloading this constructor, and the student with the first name, last name, eye color, yada, 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 is overloading this constructor as well. Overloading means it's the same method, same class method, this method that creates the object in memory, but it's now overloaded to provide different parameters. Do you all remember when we covered in class about method overloading? Okay, method overloading is exactly the same thing. Okay. Any questions with it? Okay. All right. And we are about now down to the last couple of topics here. We've talked about this. You guys understand what this is, right? The this keyword. Okay. Primitive reference types. All right. Let's go back and look at this class right here. What is different from private long, capital L, and private long what's the difference in data types?
One's a variable, and the other one's a class type.
Both of them are variables. But what's the difference? I'll show you real quick here. In IntelliJ, if you hold the control key and try to hover over this type of variable, what are you seeing? Can you do anything? What about on this one? All right. We have two different types of variables here. In Java, you have things that are considered primitives, and you have things that are considered objects. Okay? Your primitive classes would be, the easy way to remember your primitive data types are that they always are lowercase and are things like this. Char is a primitive, int, short, long, I'm not sure if, I can't remember, let's see, byte, what else? Double, float, those represent your primitives. Whereas long, if we actually go ahead and do this in IntelliJ, it'll allow you to inspect the source code. Long is a class, and long extends from number, which by default extends from what? Implicitly, all classes extend from object, okay? It extends from object. And you see over here, it also implements something. We're not really going to talk about implementing right now. I think you're going to look at it in your class a little bit, but let's go back just to the long class. Long is a object representation, or it's called a wrapper class for the primitive long. Okay? So that means in Java you can do things like this. I can specify, let's see, where's my person? There we go. I have this student like this, but I can also implicitly assign a number to it. These are special classes because typically when you create a class, you're going to do something more along the lines of new long, right? And then you're going to pass in the value. That's more along the lines of what you might be used to seeing. Okay, here it's telling us this constructor is deprecated. But classes in themselves, you're going to see them use this new, whatever the class name is, and calling the default constructor, right? Wrapper classes allow you to do things where you can assign the number directly to the object. Okay, they're special. And in some ways, you just gotta set it aside to a separate category in your mind that wrapper classes can implicitly accept primitive values. So just as there is a private long student ID, there is a wrapper version for character. Let's see. I'm trying to think of a value. So I can do that, and it implicitly accepts the primitive type. You can also do private integer. And it implicitly accepts that value. Okay? These are called wrapper types. Right? Any questions between primitives and the wrapper types, the objects? Okay. All right, so that's your your integer, your int versus the integer, right? Int is a primitive, integer is a wrapper class. All right, let's go on here. And finally, arrays. Okay, let's go back to, I'm going to take out the stuff out of the student class here real quick. We don't want to clutter this up. Yeah. There we go. All right, we're back to normal. So let's go back to our main class. And we have all of these objects in here, right? Let's kind of go back about, was it 3 or 4 weeks ago when we introduced an array? Can someone tell me what an array is?
It's just a way to like set parameters and then assign values to all of them. It stores a lot of information.
They do store a lot of information. Think of an array, the best way to do this, an array is a collection. It's a list, okay? But I always want you to connect these to what's happening in memory in RAM, okay? So an array is a set of memory locations that are all going to be the same data type, okay? So when you declare an array, you usually declare an array like this. Equals new string, and I have to specify a length, right? The number of locations that the array holds. So I'm going to specify 20. All right. This is kind of a kludgy way to deal with data sometimes. What if you could create a collection type that is dynamic? And it could hold even your newfangled person or student or staff classes. And it could hold as many as you want. You could just keep adding to it. What if that exists? Would anyone go and buy it? Right. Anyone go to the movie? I guess, right? You can go. You would go to the movie. I'm proud of you. Thank you. Let's think of it this way. Another way that I could write this object is I could say private array list name. Whoops. We got to import the array list up here. So we're going to say, there we go, name equals new array list. And for simplicity, I'm just going to comment out the above. Now, array list now gives me the ability to specify a collection that can hold as many objects as I want. And at this point, the only thing that array list can do is just hold generic objects. But array list gives me this other feature that's available in Java, and it's a greater than less than symbol. It's these brackets. And this allows you to make your class called array list generic. Meaning it's generic, it can handle anything you want it to handle as long as you specify it. So here I'm going to say my array list is going to handle a person. Now this kind of gets interesting. Let's copy all of this stuff here. I'm going to cut it out. I'm going to go down to my main method. I'm going to repaste it, but I'm going to take out the private because you can't have an access modifier inside of a method. Okay? And I'm going to say m dot name dot add. All right. Delete this one, and I'm going to come over here, cut and paste. Let's see. Reformat code. There we go. I like it to look pretty. So now I've added implicitly a new object inside of the method. I haven't had to create it and specify it with a variable because all I'm going to do is add it to this collection. And the collection is name, right? I'm going to rename this method, rename this variable because this doesn't make a lot of sense, right? Let's call this my person list. Okay? And then down here, I'll say person list. Now person list makes more sense, right? And on my person list, I'm calling the method available to it called add. And if I hover over this, see what it tells me? I can add what type of object? I can add a person. Well, how does it know I can add a person and not like a number? Well, the reason it knows that is because when I created it, I used the generics up here that say it will now accept these type of objects. So I'm giving it so it'll accept a person. All right, well, let's do this again. I'm just going to copy this information. I'm going to paste over top of student, and we'll come down here. We'll add a closing parenthesis, a semicolon, and kind of reformat my code again. So go to code, reformat code. Yeah, that's good. So now I've added a student to it, and I can add a student because a student is a what? It's a person. And the array list accepts persons now. So now I've added a student to this list of persons. Well, I think you all know where I'm going with this, right? I'm going to do it again to the staff. So I'm going to add my staff, and I think I just have to add a close parentheses there, And we'll go to code, reformat the code again. All right. Now, I've got these three methods down here that don't make sense. I'm just going to take them out. But instead, I want to iterate through my list. I mentioned a type of for loop 2 weeks ago. Do y'all remember the type of for loop that we used? Huh?
While.
You could use a while. If we did while, we would say while what? How would we iterate with a while loop? There's an easier one to use, though.
Talking about enhanced?
Uh-huh.
Enhanced?
Yeah, enhanced what?
For loop.
Okay, so we have for. We're going to say it's going to take a person, and we're going to pass in our in-person list. Now we're iterating over that. And if I do system out print line, I can say P. And I could print out the toString, or I could print out anything, right? All right, so looking at this code so far, what do I have up here? I've created a new type of array list that dynamically allows me to add as many persons as I want. I don't have to specify, hey, I can only take 20. I could add, and as I keep adding persons to the array list, it just automatically accepts them. Said, yep, come on in. Water's warm, everyone's welcome. Come on in, right? Plenty of space at the table. So it's going to take all of those, and as long as it's of the type that I specified, as long as it's of type person. So what would happen then if I tried to add something else, like, say, a new long? What's a better way of doing that? Like that, right? Can I do that? No, I can't. Because why? Because the array list is only set to accept a certain type, accept a type of person. All right. Now I want to blow your mind a little bit. What's going to happen when I iterate through my list of persons? What's going to print out? We've kind of already discussed it, right? We've talked about the toString method that we've set up. So when we call this, we'll run the main method, and we can see it prints the toString method associated with each class object. It iterates through the list, says, yep, you're a person, give me your toString method because that's what I want to call, and it calls that method. It just prints it out. All right, any questions so far? Any questions? All right, it's 5 o'clock. I'm amazed we got through all of this today. I really am, because you have 20 PAs this week. And the 20 PAs are fairly short, each one, but they go into a lot of detail discussing the many different aspects that we've covered today in class. You also have about 7 CAs this week, okay, and there's 1 lab. Okay, now I promised you I would put out a video going over the class project 2, and last week was a little bit of a strange week for me. I wasn't feeling well. So probably tomorrow I'll put out a video for you all going through the class project in more detail, and just please watch the video and take the time to implement it the way you want to implement it. Go out there, and if you still have those websites available, you can go to the ASCII art generator, and you can generate all types of pretty ASCII art. You can generate your weapons and everything that you're going to use, and it's a great way to do it, to make your project your own. Okay? All right. Guys, any questions for me? All right. I'll be here for a few minutes if you all have any other questions. Otherwise, I will see you all next week.